Hello, everybody. It's an honor to be here. And great people, great food, everything is great. Thank you for inviting me. And okay, so I'm the substitute speaker for Miss Tuba Islam. And I've been working in this domain for more than 10 years. I've completed many projects, of course, using SAS. And I have my, I studied engineering, then I studied statistics. And as a student, I started using SAS. And then still now I'm using SAS because SAS is everywhere. Wherever you go, you will see big major companies using SAS. SAS is in more than almost 150 countries, used in more than 80,000 sites, and it will be growing. So I urge all the students to learn, I encourage them to learn how to use SAS. And one of the reasons why SAS is that popular and it's used in every sector and every big bank, financial institutions, retail, or telecommunications operators, is that SAS is reinvesting 25% on research and development, whereas industry averages merely half. So let me go through my schedule. First, I will start with the commonality of use cases in unconventional sectors. And then I will mention about the ingredients of success and the challenges of them, and then real-life examples on healthcare. So, power of analytics. So, data scientists is the most wanted job in 2016 in the USA. Everyone wants to be a data scientist. Everyone is talking about big data, machine learning, cognitive computing, and that stuff. You know, that's in everybody's mouth. So, and recently I've come across in one of the web pages that professional networking web pages says that I'm supposed to know this person who is entitled a data scientist. And I know this guy from previous project, and I know what he's doing. And he wasn't a data scientist, as far as I know. And I called my friend, you know, did you start hiring data scientists? And she said no. And you know, why is this guy is a data scientist all of a sudden? You know, they implemented SAS. They bought SAS, and now they are using SAS, and now everyone in the department suddenly become a data scientist. So, and she tells me about that. They want to do the churn machine learning. They want to do machine learning. They want to take away churn prediction from the CRM department. So what's this guy doing? And she goes like, this guy is actually reporting the number of cash loans that has been sold by that bank daily basis. So, you know, this is data science, you know, so everyone is trying to take a bite of it. And there aren't many women, let me tell you. I mean, when I go to the projects, I'm almost always one of the few women in the whole floor, or in the project, or in the department. And actually, just recently, 2 days ago, in one of the biggest banks in Turkey, I had to sit with a SAS administrator to figure out what should be the best buffer size, memory size, and source size to read the 600 millions of data. You know, I'm telling you, I was the only one, apart from the secretary. Okay? So there should be more women. I encourage all the women, all these clever women, girls, students, to go into this field, because this field really needs you. So why now? Why suddenly everyone is talking about big data, machine learning, Because I think there is more data primarily, but there is now we can store more data on a cheaper rate, right? And the CPUs are faster and they are cheaper, and there are more improvements. There are more research on more clever algorithms. So these all three incubate the development of clever and more developed models. So let me go. These are just the regular conventional selection of use cases. What we do churn prediction, we do credit analysis, credit scoring, customer lifetime value, customer segmentation, and social network analysis, market basket analysis. These are just what we are doing so far. But I'm saying that we can just use the same process. We can keep the process, but we can move this to different unconventional sectors, such as healthcare. So it's the same process with different actors and we will be telling a different story. So in the customer view, we would be having profit-based customer segmentation, and in healthcare, in the patient view, we would be having cost-based patient segmentation. Instead of credit risk, we would be having risk of readmission, risk of patient is coming again to the hospital. And instead of having customer journey, we would be having patient journey. So what are the ingredients of a successful data science project? What should we do? So everything starts with data. Without the relevant data, accurate data, and accessible data, we cannot do anything. So on the basis, we should have a good data. These are the 3 Ds, by the way, 3 Ds of a successful project. And then we should have the enough expertise, and skill set, relevant skill set to play with this data and figure out a model and take out the valuable information from this data. And then we need to deploy it, right? We cannot just say, here is your, dear colleagues, here is your model, and we're just going. No, you cannot do that. You have to deploy it. You have to make sure that's automated. It's been run periodically depending on the project, and you should be monitoring it. Because without the monitor, you cannot make sure that it's stable. You cannot sure. For example, Trump has become president of the United States, and the markets are very changing now. Everything is very volatile, and you have to adjust. You have to adjust your model to go to run stable through the time. So, and these were the 3 Ds, and I'm telling you about the hidden and secret 3 Cs. So this is creativity, collaboration, and communication. So women, aren't we best in these 3 Cs? I know that in every project, if there is a woman, that project goes very smoother, faster, because women talk, women collaborate, women are one step ahead in creativity. So please, women, go into this field. So what are the challenges? These are the common challenges on each industry, in each sector. So the good quality of a data is the biggest impact on your success. And by experience, I can tell you that 70% of a model implementation or creation goes into preparation of the data. So all these IT people are preparing data for you. You should thank them, because then SAS does everything for you. So first, you need to have good IT people to prepare your data. And then you should interpret it. You should tell your project, your model, whatever you are modeling, in a very easy way. So everybody should understand what you are talking about. You cannot say, this is the black box, okay, management, this is the black box, I'm giving you, please use it, please run it regularly. You cannot say that. You have to explain this black box to the users. And then you need to deploy it, you need to implement it to the system. And then you need to check the stability. You need, for example, in credit risk, you need to, after you implement your model, you have to go there and say, or automatize it, say, this is the score stability across the periods. This is the characteristics used in the model, and this is the stability score for these variables. So healthcare is a different story. It's so much harder because it's a new subject and there isn't structured data available. And data sources are very disparate, and there is no unique index for patient, let's say. And as you might, medicine people would know, there is these ICD codes that has been built by World Health Organization, international classification codes. There are almost 15,000 of them, and they are very valuable. You are supposed to use them, and how? SAS has solutions for all of them, so relax. And so this is the image of how disparate, how different your data sources can be in healthcare. So in one dimension, you have description, demographics, descriptive dimensions, demographics of your patient, utilization and cost, whatever he's paying or he or she's paying, the segment he or she is at. And there's treatment dimensions, number of treatments, number of episodes, types of episodes, and prescriptions, whatever drugs he or she used, and the operations he or she went through. And there's another dimension, which is instead of having customer experience, we have here patient experience. It can be feedback letters, surveys that has been done on patient, and if there is available, of course, net promoter score. So it's really hard to combine all this data in a healthcare project. So this is a real-life example that has been done for NHS in the UK, and this is a presentation of how we can use SAS to enrich our data. I just mentioned about the ICD codes. There are many of them, and they are very important. You are supposed to use them, and how? Imagine for each patient, for one patient you have 200 ICD codes, ICDs, right? And for another customer you have 200 more. So in order to take out information and put it in the SAS miner, you're supposed to take the flags of it, create derived variables from it, and then suddenly, if you want to create flags of it, now for 200 and 200, 400 new variables are there. So once you transpose the data, now you have 400 variables. So it's not manageable, but thank God we have a SAS text miner. So once you load your data in SAS text miner, you can do various things. One of them was concatenate these texts, these codes into one topic. These are called topics. And just like you do principal component analysis on variables, you are trying to combine these most important and most valuable topics or ICD codes. You're just creating new variables using this codes, and then you can take out, let's say, top 20 topics. I'm going to use top 20 topics, top 50 topics. So life is so much easier. There is an example of codes that I've been talking about. So it's very detailed, as you can see. And so, for example, for each topic, you can see there are many of ICD codes inside. And there's another real-life example. This is the unsupervised and semi-supervised methods for patient segmentation. And then after that, profiling for it using decision tree. So as I mentioned, this is the prepare the data. Modeling is very hard. First, you prepare the data. And then you do a cluster analysis to create your segments. This is called unsupervised modeling. Once you determine, once you know your clusters, let me show you an example. So at this point, we know our cluster. So this cluster has been selected. So you see the purple, you see the brown segment and the purple segment on the right-hand side. So you see the purple segment, there is no utility, there is no cost, it's an idle segment. Whereas on the right-hand side, you see purple segment. These are high-cost patients, and they are coming to the hospital unplanned. So let me go back to the diagram. This is the basic diagram of a SAS minor, by the way. So after then we are in the target definition phase. Once we know our segments, we go back and dig details from this purple segment. Why is this purple segment like this? Why is that they're using the hospital that much? What can we do to know more about these patients? So this is just the basic methodology for a mining project. So we set a target. Now in this project, our target is purple segment. So purple segment patients are flagged. And there is this set roles part. This is the metadata the lady was talking about. This is the data of the data where you set what your variables are. And then you take the small sample from it because you don't have to use the whole data to figure out what's going on with your data. Then you do the data partition. So you can have your modeling data, then you can have your validation data, and then you can have a small data to test your model. And after that point, we just do grow a little tree here. The focus is just the purple segment customers, and at the back leaf, at the bottom leaf, you see that almost 75% of the patients are dropped in this leaf. So once we click on it, and we can see the English rule behind it, and then we see that there is an association between cardiac and gastro visits. So, and that rule has been given to the management, saying that, you know, these purple customers are coming because they are coming a lot to cardiac department and the gastro department. Maybe you know, these medicine people know what's behind it, but that data is already saying that. So, and there's another real life example. This was an audit project done in Denmark. So previously, doctors were filling out the reports, right? So most of them, they are empty because they don't have time. I'm sorry. They don't have time, or maybe they're just forgetting to fill some fields. So by the audit department of this hospital, only 1% of these reports were taking, and then trying to fill these empty blanks, empty fields. So, but it was time consuming. For each patient, for each report, it was taking 10 minutes. So by using SAS text miner, these fields are filled with a very clever algorithm, and the management was really happy about it. So this is just an example of it. So I mean, we don't have to use SAS just for these sectors. There's a, I don't know if you know that there is a Data for Good initiative. SAS is part of it, and World Wildlife Fund has been using SAS to predict the donors that will be giving most donors and to this initiative. And there's another one which is very important for us, teaching coding to women in Ghana is part of this initiative and part of SAS too. So that's about it. Thank you for listening. If you have any questions, I can take.
Thank you very much. I'm sure that many young women here have been inspired by your presence and will be seriously considering going into this data analysis world. We have time for one very brief question. Otherwise, we can proceed with the next. Okay, so we'll move on.
There is one gentleman.
Yes?
I couldn't hear, I'm sorry.
If one sees job descriptions for data science online, most of the time they ask for Python and R.
Yes.
Because now, you know, the state-of-the-art libraries mostly are written in Python by leaders like Google. What's the advantage of using SAS here? What's the difference, and
yes.
does it bring any advantage?
I mean, in the sector, you will see that every major company, every big bank, financial institution is using SAS as their primary statistical software. As I mentioned, it's over 100 countries, more than 80 cases. You can learn Python too. I know Python, but I mean, you cannot go to a bank and set up, you cannot use Python very easily. It's not set up. So SAS is everywhere. As a student, if you learn SAS, you will be very lucky. I mean, you will be selected very easily by these big companies.
Yeah, but most of them are using Python at this moment, no? Am I wrong?
Actually, there's
Not banks. I mean, just like regular, anything but banks.
Yeah, I mean, that is true. I know Python too, and I love coding Python. And SAS is actually using Python behind the text mining. So behind the text mining product. Python is good too, but SAS is more. How do I say? Widespread, yeah. Yeah, and more user-friendly, actually. I mean, only coders can code Python, but SAS has a user interface, which is like, as I mentioned previously, that gentleman who is just doing the reporting is using SAS without knowing any coding. He's just, using the interface. And so it's user-friendly.
Okay, I see. And can it support like massive data sets?
Actually, in my just 2 days ago, we've been dealing with 600 million of observations in transactional format, transactional data, and it has no problem. Yeah, it's very. I mean, it's depending on the server, of course, depending on the machine, and SAS can alter these without problem, definitely.
Okay, thank you.
Thank you. Okay.
Thank you.